Note 6.5 Part 1, Graphing Inequalities. Objectives are to determine the boundary line and graph the solution of an inequality. Just to review our inequality symbols, please remember that we read them from left to right. This would be a greater than, this is a greater than or equal to. Here is a less than symbol, and this is a less than or equal to. We will be graphing linear inequalities, and the solutions look like this. Notice that this inequality is in slope-intercept form, and the boundary line is graphed accordingly. This begins at 2 and has a slope of a rise of 2 and a run of 1. Notice that our line is dashed, not solid, and notice that we have just a greater than symbol. In the second example, it's also in slope-intercept form. So when you graph the boundary line, you begin at -2, has a rise of 2 and a run of 3. A boundary line is dashed, and looking at less than, you can see it shaded below the line. In the third example, it is a y is greater than or equal to 4x plus 1. This line begins at 1 on the y-axis, has a rise of 4 and a run of 1. Greater than is shaded above, and it's a solid boundary line. So some rules on graphing inequalities are as follows. The solution to a linear inequality is called a half plane. So a boundary line that divides the coordinate plane, and it divides it into two half planes. The boundary line is included in the solution when the inequality is a greater than or equal to or a less than or equal to. When the boundary line is included in the solution, the boundary line will be solid, like we saw in the third example above. The boundary line is not included in the solution when the inequality is a greater than or a less than. When the boundary line is not included in the solution, the boundary line will be dashed, like in examples 1 and 2 above. Now, one of the half planes will be the solution side, and the coordinates on that side of the boundary line, when substituted into the inequality, will make it true. Obviously, the coordinates on the other side of the boundary line will make that inequality false. You will indicate the solution side or the true side by shading that half plane. So, at the bottom, 5 steps in graphing an inequality in slope-intercept form. You first graph the boundary line for the related equation. You determine if the boundary line is solid when you have a greater than or equal to or less than or equal to, or is it dashed, which is a greater than or less than. You're going to pick a test point in either half plane. If possible, and if it's not part of the line, we love 0, 0 because it's really easy to substitute 0 in for x and y. You will then determine if the test point is true or false for the inequality, and you will shade the side of the true results.